Welcome to this Python complete course for beginners. We are going to learn Python from the basics. Python is a popular programming language that is easy to read, easy to write, and beginner friendly. Python is used in many areas such as web development, data science, machine learning, automation, scripting, app development, and artificial intelligence. One of the main reasons to learn Python is that its syntax is simple compared to many other programming languages. This makes it a great first programming language for beginners. In this course, we shall go through these topics one by one, with detailed explanations of the concepts and step-by-step examples. By the end of this course, you should have a strong foundation in Python programming. Now, let us begin by setting up Python on our computer. To write and run Python programs, we need two main things. First, we need to install Python. Second, we need a code editor where we can write our Python code. To install Python, go to the official Python website, python.org/downloads. If you are using Windows, the Python downloads page gives you two main routes. The first route is the Python install manager. This is useful if you want a simple way to install Python and manage Python versions on Windows. The second route is the latest Python 3 release. At the time of making this course, the latest Python version shown here is Python 3.14.6. This lets you download the regular Python installer directly. For beginners, either route is fine, but the regular Python 3 installer is the easiest to understand. During installation, make sure to select the option that says Add Python to Path. This helps you run Python from the command prompt. If you are using Mac, download the macOS installer from the same Python downloads page. Install it like any other Mac application. If you are using Linux, Python may already be installed. You can check it from the terminal. If it is not installed, you can install it using your Linux package manager. For example, on Ubuntu, you can install Python using the apt command. After installing Python, we need a code editor. For this course, we will use Visual Studio Code. Visual Studio Code is lightweight, beginner-friendly, and works well for Python programming. You can download it from code.visualstudio.com. Based on your operating system, you can download the appropriate installer. PyCharm is another popular editor made especially for Python development. But in this course, all examples will be shown using Visual Studio Code. If you already use a different editor, that is also fine. The Python code will work the same. After installing Python, open a terminal or command prompt. To check the Python version, type Python space -- version and press enter. On Mac or Linux, if that command does not work, try Python 3 space -- version. If you see a Python version number, then Python is installed correctly. Now we are ready to write our first Python program. Before we open Visual Studio Code, let us create a separate folder for our Python programs. On Windows, you can create this folder in File Explorer. On Mac, you can create this folder in Finder. You can name the folder something like Workspace. A workspace is simply a folder where we keep our project files. For this course, we will use this Workspace folder. Now, open Visual Studio Code. In Visual Studio Code, open the folder that we just created. This helps Visual Studio Code understand that this folder is our current project workspace. Now, let us create our first Python file. In the left sidebar, Explorer. Right-click in this space and click New File option. Or you may click this New File button. Name the file helloworld.py. Here, the file name is Hello World and the extension is .py. The .py extension tells the computer that this is a Python file. So whenever we write Python code, we usually save the file with the .py extension. Inside this helloworld.py file, write this line. Print, open bracket, double quote, hello world, double quote, close bracket. This print statement displays hello world in the output. Now save the file. Control S on Windows or Linux, Command S on Mac. We can run the program in different ways. One common way is to use the Run button in Visual Studio Code. Or you can open a terminal from the menu options and then run the Python command in the terminal. The syntax is Python 3 space file name. For example, Python 3 space hello world.py. If you see hello world in the output, your Python setup is working correctly. When we run this program, Python reads the hello world.py file from top to bottom. It sees the print statement. Then it prints hello world in the output or terminal. We write instructions in a .py file, save the file, and then ask Python to execute those instructions. We have successfully written and run our first Python program. Here, print is a function that is used to display output on the screen. Anything that we place inside the brackets is displayed in the output. In this example, we are displaying the text hello world. Notice that the text is enclosed within double quotes. This tells Python that hello world is a string. A string is simply a sequence of characters. Now let us understand comments. Comments are notes that we write inside our source code. Python ignores comments while running the program. To write a single line comment, use the hash symbol. For example, hash symbol space, this is my first Python program. Run the program. This line is ignored by Python. What is the use of comments if they are never executed? Comments make your programs easier to understand, especially when the programs become larger. Now let us look at some basic Python syntax. Python is a case-sensitive programming language. This means that uppercase and lowercase letters are treated differently. For example, print in lowercase is the correct function. If you write print with a capital P, Python will generate an error. Whenever you see an error message, do not panic. Read the error carefully. Most of the time, the problem is a typing mistake, a missing bracket, or a missing quotation mark. Finding and fixing errors is a normal part of programming. In this specific example, we got name error with detailed message that the name print is not defined. We can also see the file name and the line number where the error occurred. Now, we can go to that specific line and fix the error. The message said print with capital P is not defined. There is no function that is built in Python with that name, and neither did we create such function. The more programs you write, the easier it becomes to identify and correct these mistakes. Python also requires matching brackets and quotation marks. Whenever you open a bracket, you must close it. Whenever you open a quotation mark, you must also close it. Let us learn about variables in Python. Variables are used to store data. Creating a variable in Python is very simple. We just write the variable name followed by an equal sign and then the value. Let us create another Python file, demo.py. We shall use this file hereafter. Let us create a variable in this file. For example, name equals within double quotes Krishna. You can think of a variable as a container that holds a value. Here, the variable name stores the text Krishna. Now, let us print the name to output. We already know that we can use print function to display data, and anything that we need to display should be given inside brackets. Inside brackets, the name variable. We stored the string value in name variable and we used the variable whenever we needed it. Similarly, age equals 25. Here, the variable age stores the number 25. Notice that we do not need to tell Python the data type like in other programming languages like C or Java. Python automatically understands whether the value is text, a number, or some other type. Now let us print the age as well. Run the program. Python displays the string Krishna for the first print statement and 25 for the second print statement. Now let us talk about variable naming rules. A variable name can contain letters, numbers, and the underscore character. However, a variable name cannot begin with a number. For example, student underscore name and marks underscore 1 are valid variable names. One student is not valid because it starts with a number. And check if Python raises an error for the invalid variable name. Python says that it is invalid decimal literal. We already learned that Python is case sensitive, which means variable names are also case sensitive. The variables age with all small case or age with a uppercase or age with all uppercase are different from each other. For example, let us define these three different variables and assign some values to them and print them in respective print functions. Run the program. As we can see, Python treats them as completely different variables. It is also a good practice to choose meaningful variable names. For example, if we need to store the name of a student in a variable, student underscore name is much better than X. Meaningful names make your programs easier to read and understand. Another important rule is that we cannot use Python keywords as variable names. Keywords are special words that already have a specific meaning and purpose in Python. Therefore, we cannot use keywords as variable names. We can write an example. If is a keyword in Python. Let us try to assign a number, if equals 25, and run the program. We get a syntax error. So clearly, we should not use Python keywords as variable names. Now let us see how to change the value of a variable. Suppose we can write score equals 50. Later in the program, we can write score equals 80. Now the variable score stores the new value. The old value is replaced. If we print score, the output will be 80. Variables can be updated as many times as we want. This is one of the reasons they are called variables, because their values can vary during the execution of a program. Now let us learn about multiple assignment. Python allows us to assign values to multiple variables in a single line. For example, x, y, z equals 10, 20, 30. Now x stores 10, y stores 20, and z stores 30. Let us print each of these variables to output. X is 10, y is 20, and z is 30. We can also assign the same value to multiple variables. For example, a equals b equals c equals 100. Now all three variables contain the value 100. Multiple assignment makes the code shorter and easier to read when used appropriately. Let us quickly review what we learned about variables. Variables are used to store data. Python automatically determines the data type. Choose meaningful variable names and follow the naming rules. Variables can be updated by assigning a new value. And multiple assignment allows us to assign values to several variables in a single statement. Now that we know how to store values in variables, let us understand the different types of data that Python can store. Every value in Python belongs to a particular data type. A data type tells Python what kind of value it is working with. For example, a whole number, a decimal number, some text, or a true or false value. Let us look at the most commonly used data types in Python. The first data type is int. The word int stands for integer. Integers are whole numbers without any decimal point. For example, 10, -5, 0, or 1000. Let us create a variable. Age equals 25. Here, 25 is an integer. The next data type is float. A float is a number that contains a decimal point. For example, 3.14, 99.5, or -0.75. Let us create another variable. Price equals 99.99. Here, 99.99 is a floating point number. The next data type is str. The word str stands for string. A string is used to store text. Anything written inside single quotes or double quotes is treated as a string. For example, name equals within double quotes Krishna, or city equals single quote Hyderabad single quote. Both are strings. Strings can contain letters, numbers, spaces, and special characters. For example, let us store an email address in a variable. Email equals, in double quotes, student1@example.com. This string contains letters, numbers, and special characters such as the @ symbol and the dot. As long as the value is inside quotes, Python treats the entire value as text. The next data type is bool. The word bool stands for boolean. A boolean value can have only one of two values, true or false. Notice that both true and false begin with a capital letter. For example, is underscore logged underscore in equals true, or is underscore raining equals false. Boolean values are mainly used when we need to make decisions in our programs. We will learn more about them when we come across conditions and if statements. The next data type is none. None represents the absence of a value. You can think of it as saying this variable does not have any value right now. For example, result equals none. Notice that none also begins with a capital N. It is a special value in Python and it is different from 0, an empty string, or false. Now you might be wondering, how do we know the data type of a value? Python provides a built-in function called type. The type function tells us the data type of any value or variable. For example, print within brackets type within brackets age. Since age contains the integer 25, Python displays class int. Similarly, print within brackets type price. Python displays class float. We can also check the type of strings. Print within brackets type of name. The output is class str. Now let us check the type of the variable is underscore logged underscore in. Python displays class bool. And if we check the type of a variable containing none, Python displays class none type. Whenever you are unsure about the type of a value, simply use the type function. Let us quickly review what we learned about data types. The int data type is used for whole numbers. The float data type is used for decimal numbers. The str data type is used for text. The bool data type stores either true or false. The none value represents the absence of a value. And the type function helps us find the data type of any value or variable. Now that we understand data types, let us learn about type conversion. Sometimes we need to change a value from one data type to another. This process is called type conversion. Python provides built-in functions to perform type conversion. The most commonly used ones are int, float, and str. Let us start with the int function. The int function converts a value into an integer. For example, assign number variable with the int function passing the string with characters 100. Here, the int function converts the given string into integer value 100. Let us print the number to output. And if we check its type using the type function, Python displays class int. Now let us look at another example. Value equals int within brackets give 9.8. Here, the float value 9.8 is converted into an integer. The decimal part is removed and the result becomes 9. Notice that Python does not round the number. It simply removes everything after the decimal point. Next, let us learn about the float function. The float function converts a value into a floating point number. For example, price equals float function within brackets give a string value 50.23 and then print the value returned by float and the type of that value. The string 50 is converted into the floating point number 50.23. Similarly, marks equals float inside brackets 80. Since 80 is an integer, Python converts it into float value 80.0. Now let us learn about the str function. The str function converts a value into a string. For example, age equals 25. Now we write text underscore age equals str function pass the age which has integer value 25. Print the value returned by the str function. The output is 25, but we do not know for sure if it is string or integer. Let us print the type of text underscore age. Python displays class str. So even though the output looks the same, the data type has changed. Now let us understand why type conversion is important. Suppose we have a string within quotes 25. Now we want to add the integer number 5 to the string. Like an arithmetic addition operation. Try running the program. Python gives an error. This is because double quote 25 double quote is a string while 5 is an integer. Python cannot directly add a string and an integer. To solve this problem, we first convert the string into an integer. For example, result equals int in brackets 25 plus 5. Now the string is converted into the integer 25. The addition of integer 25 and integer 5 should give us 30. The result becomes 30. This is one of the most common uses of type conversion in Python. Let us quickly review what we learned. The int function converts values into integers. The float function converts values into floating point numbers. The str function converts values into strings. Okay, so far all our programs displayed fixed values. Now let us learn how to take input from the user and display output in Python. For example, a program may ask for your name, your age, or your city. To read information from the user, we can use input function. Let us write a simple example. Create a variable, name, assign it the result of the input function. The value that we enter shall now be stored in the variable name. Inside the input function, we can give a prompt string as argument. This prompt string is displayed in the terminal when input function executes. We can prompt the user, enter your name. After that, let us print the user entered name to the output. Now, run the program. The prompt is shown and the program now waits for us to type something. You see this rectangular cursor after the prompt? That is where it starts reading your input. Type some name. As we started typing some text, the entered value is echoed in the terminal. After entering the complete name, press enter or return key. Let us understand what happened here. When Python sees input function, it displays the prompt message and waits for user input. When user types the value and press enter or return key, the entered value is returned by the input function, which we are storing in a variable name. After that, the print function displays the name. Now let us take another example. Create a variable named city. Write city equals input function and for the prompt, write enter your city. Now print the city variable. Run the program. Enter the name of your city. The same value is displayed in the output. The input function always returns the value as a string. Even if the user enters a number, Python stores it as string. Let us understand this with an example. Create a variable age. Age equals input function. Enter your age. Now print the age variable. In addition to that, let us print the type of age using type function. Run the program. The value is displayed correctly. And for the type we get class str. Remember that input function always returns a string. How do we convert this string into an integer? In the previous section, type conversion, we learned that we can use int function to convert a string to an integer. Let us pass the whole input function call as argument to the int function. This statement first reads the value entered by user and returns as a string. Then we are passing the return string to the int function. Int function, as we know, converts to integer. Run the program, enter some age. Observe what has been printed to the output for the type of age. Age is now an integer. Now, let us learn how to print formatted output. Suppose we want to display a complete sentence instead of printing each value separately. One way is to use commas inside the print function. For example, read name from the user using input and then print string hello, comma, name. Print can take more than one value where the values are separated by comma. If the user enters Arjun, the output becomes hello Arjun. Python automatically places a space between the values when printing to output. Although this works, Python provides an even better way to create formatted output. This is called an F string. F stands for formatted. An F string allows us to combine text and variables in a simple and readable way. Let us write an example. Write print within brackets. A formatted string starts with letter F followed by quotes. Now inside the quotes, hello. Within curly braces, name. Note that inside the string, we place the variable name inside curly braces. Now run the program. Enter your name. The output becomes hello Arjun. In a formatted string, Python automatically replaces the variable inside the curly braces with its value. We can include more than one variable in an F string. For example, let us read both name and age from the user. In the formatted string, let us write my name is, name enclosed in curly braces, and I am, age in curly braces. Run the program. Enter your name and your age. Python displays a complete sentence with both values. We use the input function to receive information from the user. The input function always returns a string. We can display one or more values using the print function, and we can create clean and readable output using F strings. Python operators. Operators are special symbols that allow us to perform different operations on values and variables. For example, we can add numbers, compare two values, or combine multiple conditions using operators. Python provides several categories of operators. These are arithmetic operators, assignment operators, comparison operators, logical operators, bitwise operators, membership operators, and identity operators. Do not worry if these names look unfamiliar right now. We will learn each category one by one with simple examples. Let us start with arithmetic operators. Arithmetic operators are used to perform mathematical calculations. For example, addition, subtraction, multiplication, division, floor division, modulus, and exponentiation. Addition. Suppose we create two variables. Price is equal to 10. Tax is equal to 3. Add price and tax. The plus symbol represents the arithmetic addition operator. The plus operator takes two operands. One operand is on the left and the other operand is on the right. Assign price plus tax to the variable named total. Price plus tax is called an expression. This expression performs the addition and returns the resulting value. We then assign the return value to a variable named total. Now let us print the total. Call the print function and within the brackets pass the total. When we run the program, the output is 13. Price is 10, tax is 3, price plus tax is 10 plus 3. So, total is 13. Subtraction. Suppose we create two variables. Price is equal to 10, discount is equal to 3. Now let us perform subtraction. Subtract discount from price. The minus symbol represents the arithmetic subtraction operator. Assign the result of price minus discount to pay. Pay is equal to price minus discount. Now let us print the pay variable. When we run the program, the output is 7. Price is 10, discount is 3, price minus discount is 10 minus 3. So pay is 7. Multiplication. Suppose we create two variables. Boxes is equal to 3. Apples per box is equal to 10. Now let us perform multiplication of these two variables. The star symbol represents the arithmetic multiplication operator. Assign the result of boxes multiplied by apples per box to the variable named total number of apples. Now let us print the total number of apples. When we run the program, the output is 30. Boxes is 3. Apples per box is 10. Their product is 30. Division. Suppose we have total candies is equal to 24 and children is equal to 6. Now let us divide the total candies among the children. We need to perform the division of total candies by children. The / symbol represents the arithmetic division operator. Store the resulting value in variable candies per child. Now let us print the candies per child. When we run the program, the output is 4.0. Total candies is 24. Children is 6. 24 divided by 6 is 4. So each child gets 4 candies. Floor division. Floor division returns only the whole number part of the quotient. For example, 25 divided by 4 is equal to 6.25. But 25 floor divided by 4 is equal to 6. The decimal part is discarded and only the whole number is returned. Suppose we have total chocolates is equal to 25 and children is equal to 4. The class teacher wants to distribute the chocolates equally among the children. Since a chocolate cannot be split, any remaining chocolates will stay with the teacher. So, we need to perform floor division of total chocolates by children. The / symbol represents the arithmetic floor division operator. Store the resulting value in the variable chocolates per child. Now let us print the chocolates per child. When we run the program, the output is 6. Total chocolates is 25. Children is 4. 25 divided by 4 is 6.25. Floor division returns only the whole number part, which is 6. So each child gets 6 chocolates and 1 chocolate is left with the teacher. Modulus. The modulus operator returns the remainder after a division. For example, 25 divided by 4 gives a quotient of 6 with a remainder of 1. The modulus of 25 and 4 is equal to 1. Let us take the same previous example. Total chocolates is equal to 25 and children is equal to 4. The class teacher wants to distribute the chocolates equally among the children. Since a chocolate cannot be split, some chocolates may be left over. We need to find how many chocolates remain after giving each child an equal number of chocolates. The percentage symbol represents the arithmetic modulus operator. Store the resulting value in the variable remaining chocolates. Now let us print the remaining chocolates. When we run the program, the output is 1. Total chocolates is 25. Children is 4. 25 divided by 4 gives each child 6 chocolates with 1 chocolate left over. The modulus operator returns this remaining value, which is 1. Exponentiation. The exponentiation operator raises a number to the power of another number. For example, 5 raised to the power of 3 is equal to 125. Suppose we have side length is equal to 5 and power is equal to 3. We want to calculate the volume of a cube. To do that, we raise the side length to the power of 3. The * symbol represents the arithmetic exponentiation operator. Store the resulting value in the variable cube volume. Now let us print the cube volume. When we run the program, the output is 125. Side length is 5, power is 3. 5 raised to the power of 3 is 125. So, the volume of the cube is 125 cubic units. Let us quickly review the arithmetic operators that we have learned. The addition operator, represented by the plus symbol, is used to add two values. The subtraction operator, represented by the minus symbol, is used to subtract one value from another. The multiplication operator, represented by the star symbol, is used to multiply two values. The division operator, represented by the / symbol, divides one value by another and returns the quotient as a floating point number. The floor division operator, represented by the double / symbol, divides one value by another and returns only the whole number part of the quotient. The modulus operator, represented by the percentage symbol, returns the remainder after division. The exponentiation operator, represented by the double star symbol, raises a number to the power of another number. Take a moment to review the table. Assignment operators. The equals operator assigns a value to a variable. For example, a equals 10 stores the value 10 in a. The plus equals operator adds a value to the current value of a variable and stores the result back in the same variable. The minus equals operator subtracts a value from the current value of a variable and stores the result back in the same variable. The multiplication equals operator multiplies the current value of a variable and stores the result back in the same variable. The division equals operator divides the current value of a variable and stores the result back in the same variable. We have already used the equals operator many times. The equals operator assigns the value 50 to the variable named score. The plus equals operator adds a value to the current variable and stores the updated result in the same variable. Run the program. The statement score plus equals 10 is a shorter way of writing score equals score plus 10, which is 50 plus 10. Score is 60 now. Now let us use the same score variable with the other assignment operators. The minus equals operator subtracts a value. The multiplication equals operator multiplies the current value. The division equals operator divides the current value. Run the program. Please note that assignment operators update the values stored in the variable. We started with score equals 60. Then score minus equals 10 is a shorter way of writing score equals score minus 10. 60 minus 10 is 50. Therefore, score is updated to 50. Python then prints 50. Next, score multiplication equals 2 is a shorter way of writing score equals score multiplied by 2. At this point, score contains 50. 50 multiplied by 2 is 100. Therefore, score is updated to 100. Python then prints 100. Finally, score division equals 5 is a shorter way of writing score equals score divided by 5. At this point, score contains 100. 100 divided by 5 is 20.0. Python then prints 20.0. Comparison operators compare two values. The result of a comparison is a Boolean value. A Boolean value is either true or false. The equal to operator, written as double equals, checks whether two values are equal. The not equal to operator, which is written as exclamation equals, checks whether two values are not equal. The greater than operator checks whether the value on the left is greater than the value on the right. The less than operator checks whether the value on the left is less than the value on the right. The greater than or equal to operator checks whether the value on the left is greater than or equal to the value on the right. The less than or equal to operator checks whether the value on the left is less than or equal to the value on the right. Do not confuse the single equals operator with the double equals operator. A single equals sign assigns a value to a variable. A double equals sign compares two values. Let us use all the comparison operators in one program. Create two variables named number 1 and number 2. Assign 10 to number 1. Assign 20 to number 2. Each print statement checks one comparison. Now let us run the program and see the results. Let us understand each comparison. The first statement checks whether number 1 is equal to number 2. 10 is not equal to 20. Therefore, the result is false. The second statement checks whether number 1 is not equal to number 2. 10 and 20 are different values. Therefore, the result is true. The third statement checks whether number 1 is greater than number 2. 10 is not greater than 20. Therefore, the result is false. The fourth statement checks whether number 1 is less than number 2. 10 is less than 20. Therefore, the result is true. The fifth statement checks whether number 1 is greater than or equal to number 2. 10 is neither greater than nor equal to 20. Therefore, the result is false. The sixth statement checks whether number 1 is less than or equal to number 2. 10 is less than 20. Therefore, the result is true. Now let us change the values and run the same comparisons again. Assign 20 to number 1. Assign 20 to number 2. Run the program. Let us understand the new results. The first statement checks whether number 1 is equal to number 2. Both values are 20. Therefore, the result is true. The second statement checks whether number 1 is not equal to number 2. The values are equal. Therefore, the result is false. The third statement checks whether number 1 is greater than number 2. 20 is not greater than 20. Therefore, the result is false. The fourth statement checks whether number 1 is less than number 2. 20 is not less than 20. Therefore, the result is false. The fifth statement checks whether number 1 is greater than or equal to number 2. The values are equal. Therefore, the result is true. The sixth statement checks whether number 1 is less than or equal to number 2. The values are equal. Therefore, the result is true. This shows that comparison results change when the values change. Each comparison always produces either true or false. Logical operators combine or modify conditions. Python provides 3 logical operators. The AND operator checks 2 conditions. It returns true only when both conditions are true. The OR operator also checks 2 conditions. It returns true when at least one condition is true. The NOT operator works with one condition. It reverses the Boolean result. If the condition is true, NOT changes it to false. If the condition is false, NOT changes it to true. Let us use all 3 logical operators in one program. Create a variable named age and assign 20 to it. Create another variable named isStudent and assign true to it. Each print statement checks one logical operator. Now let us run the program and see the results. Let us understand each expression. The first expression uses the AND operator. The first condition checks whether age is greater than or equal to 18. The second condition checks whether age is less than or equal to 60. 20 is greater than 18, so this condition is true. 20 is less than 60, so this condition is also true. Because both conditions are true, the AND operator returns true. The second expression uses the OR operator. The first condition checks whether age is less than 18. The second condition checks the value of isStudent. 20 is not less than 18, so this condition is false. The value of isStudent is true. Because at least one condition is true, the OR operator returns true. The third expression uses the NOT operator. The value of isStudent is true. The NOT operator reverses true to false. Therefore, the expression returns false. Now let us change the values and run the same expressions again. Assign 65 to age. Assign false to isStudent. Run the program. Let us understand the new results. The first expression uses the AND operator. The first condition checks whether age is greater than or equal to 18. The second condition checks whether age is less than or equal to 60. 65 is greater than 18, so this condition is true. 65 is not less than or equal to 60, so this condition is false. Because both conditions are not true, the complete expression returns false. The second expression uses the OR operator. The first condition checks whether age is less than 18. The second condition checks the value of isStudent. 65 is not less than 18, so this condition is false. The value of isStudent is false. Because neither condition is true, the complete expression returns false. The third expression uses the NOT operator. The value of isStudent is false. The NOT operator reverses false to true. Therefore, the expression returns true. This shows that logical expressions produce different results when the values change. Python has several other operators as well. We will discuss them in detail later when we use them in specific contexts. Python strings. A string is a sequence of characters. In Python, we create a string by enclosing the characters within quotation marks, either single quotes or double quotes. Now let's see a few examples of creating strings in Python. First, we create a string Krishna using single quotes and store it in a variable called name. Next, we create another string Delhi using double quotes and store it in a variable called city. Both single quotes and double quotes create string values. We can also create an empty string by using two quotes with nothing between them. Let us use a type function to check the data type of these variables. Print type of name, print type of city, print type of empty string. The output shows that they all belong to the string data type. Now let's understand how quotation marks are used with strings in Python. We have seen that Python allows us to create strings using either single quotes or double quotes. In most cases, we can choose either single quotes or double quotes. The choice becomes important when the text itself contains an apostrophe or quotation marks. Suppose we want to store the sentence, "It's a beautiful day." If we use single quotes to define the string, the apostrophe inside the string will be mistaken for the end of the string. We can use double quotes to define the string. Now the apostrophe is treated as part of the text. Similarly, suppose we want to store the sentence, Python is easy to learn. Because the sentence contains double quotes around the word easy, we can enclose the complete string within single quotes. The double quotation marks are now treated as part of the string. Let us print these string values and verify the output. The quotes inside the strings are preserved. Sometimes we may need to use the same type of quotation mark both inside and outside a string. In that case, we place a backslash before the quotation mark inside the text. If we enclose a string in single quotes, then we need to place a backslash before the single quotes in that string. This is called escaping the quotation mark. The backslash tells Python that the apostrophe is part of the string and does not end it. Similarly for double quotation marks, when we print these strings, the backslashes are not displayed and the quotation marks are preserved. The backslash can also be combined with certain characters to represent special actions. These combinations are called escape sequences. Let us begin with backslash n. Backslash n adds a new line inside a string. For example, message equals, in double quotes, hello, backslash n, welcome to Python. Now, let us print message. The output appears on two lines. Hello appears on the first line and welcome to Python appears on the next line. The characters backslash and n are not displayed. Together, they tell Python to move the following text to a new line. Next, let us look at backslash t. Backslash t adds a horizontal tab space inside a string. For example, we write details equals, in double quotes, name backslash t Krishna. When we print details, Python adds a tab space between name and Krishna. Now suppose we want to include an actual backslash in a string. Since the backslash normally begins an escape sequence, we write two backslashes. For example, we write path equals, in double quotes, c colon backslash backslash users backslash backslash Arjun. When we print path, Python displays c colon backslash users backslash Arjun. Each pair of backslashes in the code produces one backslash in the output. Python multi-line strings. For text that spans multiple lines, Python provides triple quotes. For example, we write address equals triple double quotes. Write some text with line breaks and at the end close this string with triple double quotes. We have written multiple lines in this string. In fact, we have written 5 lines. When we print address, the output appears on multiple lines. Triple quotes can be either 3 single quotes or 3 double quotes. Let us check the same string with 3 single quotes. Works the same way. A string is an ordered sequence of characters. Each character in a string has a position called an index. Let us create a string. The string Python contains 6 characters. Python uses zero-based indexing. This means that the first character, P, is at index 0. The second character, Y, is at index 1. T is at index 2. H is at index 3. O is at index 4. N is at index 5. To access a character, we write the variable name followed by its index inside square brackets. Let us print the character at index 0. Word inside square brackets 0. The output is P because P is the first character and its index is 0. Now let us print the character at index 2. The output is T because T is at index 2. Python also supports negative indexing. Negative indexing counts characters from the end of the string. The last character, N, is at index -1. The second last character, O, is at index -2. H is at index -3. T is at index -4. Y is at index -5. P is at index -6. For example, let us print the character at index -1. The output is N. To get the first character of a string, we use index 0. To get the last character, we can use index -1. Using -1 is easy because there is no need to find length of the string and subtract -1 to find the last character. Now, let us see what happens if we use an index that does not exist within the string. For example, the string Python has indexes from 0 to 5. If we try to access index 6, Python displays an index error. The message says that the string index is out of range. This happens because there is no character at index 6. The same error can occur when a negative index goes beyond the beginning of the string. For example, word in square brackets -7 is also invalid. We learned how to access a single character using an index. Now, let us learn how to access multiple characters at once using string slicing. Slicing allows us to extract a part of a string. The basic syntax is string, open square bracket, start, stop, close square bracket. The start index tells Python where to begin. The stop index tells Python where to stop. However, the stop index is not included in the result. Let us understand this with an example. Suppose we have the string word equals Python. If we write word within square brackets 0:4 pyth, slicing starts from index 0 and stops just before index 4. Notice that index 4 is not included. Please remember that start index is inclusive, but stop index is not. Suppose we do not write the start index. If we write word within square brackets :4, Python assumes the start index is 0. So the output is again pyth. Next, let us omit the stop index. If we write word within square brackets 2: slicing starts from index 2 and continues until the end of the string. Slicing also works with negative indexes. Suppose we write word within square brackets -4: -1. Slicing starts from index -4 and stops just before index -1. Just like positive indexes, the stop index is still excluded. We can also specify a step value. The syntax becomes string within square brackets start: stop: step. The step tells Python how many characters to skip each time. For example, word within square brackets 0:6: 2. The output is PTO. Python selects every second character. Now, let us see a very useful shortcut for reversing a string. If we give a step value of -1 with no start or stop, the slicing mechanism reverses the string. A step value of -1 moves through the string backwards. This reverses the entire string. Python provides the length function, len, to find the number of characters in a string. Let us create a variable named message. Now pass message to the length function. Store the return value in a variable named message length and print it. Run the program. The length function counts every character in the given string. This includes letters, spaces, and any special characters. In the given string, there are 14 characters in total, including the 2 spaces between the 3 words. We can combine strings using the plus operator. This is called string concatenation. Let us create 2 variables. Create first name and assign the string Arjun to it. Then create last name and assign the string Palwai to it. Now create another variable named full name. Concatenate first name and last name using the plus operator and assign the result to full name. Print full name. Run the program. Python joins the 2 strings in the same order in which we wrote them. Since we did not provide a space between them, Python joins them directly. That is why the output is Arjun Palwai without any space between the 2 names. If we want a space between the first name and last name, we have to add it ourselves. Between first name and last name, add a string containing 1 space. Run the program again. This time, Python first takes the value from first name, then it adds the space. After that, it adds the value from last name. Therefore, output contains space between the 2 names. We can also repeat a string using the multiplication operator. Create a variable named word and assign hi followed by a space to it. Now multiply word by 3 and print this value. Run the program. Python repeats the string 3 times. String upper method returns a copy of the string converted to uppercase. Let us create a variable named message and assign lowercase good morning to it. Then call the upper method on message. Store the return value in a new variable named new message. Print both the message and new message. Run the program. The first print statement displays the original value, good morning, with all lowercase letters. The second print statement displays the value returned by the upper method, good morning, with all uppercase letters. The original string remains unchanged. The upper method created and returned a new string with all the characters from the given string converted to uppercase. We can compare strings using comparison operators. Let us begin with the equality operator. Create 2 variables named word1 and word2. Assign happy birthday to both variables, then compare them using the double equal operator and print the result. Run the program. The double equal operator checks whether both strings have the same value. Here, both strings contain exactly the same characters. Therefore, the comparison returns true. We can also check whether 2 strings are not equal. Use the not equal operator. Run the program. The not equal operator checks whether the 2 values are different. Since both strings are the same, the result is false. String comparisons are case sensitive. This means that uppercase and lowercase letters are treated as different characters. Assign happy birthday with all lowercase to word 2, then compare them. Run the program. The words may look similar to us. The first string contains uppercase H and B, while the second string contains lowercase h and b. Therefore, Python treats them as different strings, and the comparison returns false. The find method searches for text inside a string. It returns the index where the text first appears. Create a variable named message and assign Python is easy to learn to it. Now call the find method on message. Pass the string easy as the value to search for. Store the return value in a variable named position. Then print position. The find method searches the string from left to right. The word easy begins at index 10. Therefore, find returns 10. Now let us search for a value that is not present. Pass Java to the find method. Run the program. The string Java is not present in message. When find cannot locate the requested text, it returns -1. The replace method returns a new string in which specified text is replaced with different text. Create a variable named message and assign Python is easy to it. Now call the replace method on message. Pass easy as the first argument. This is the text that we want to find. Pass powerful as the second argument. This is the text that should replace it. Store the return string in a variable named new message. Now print this new message variable. Run the program. Python finds easy in the original string and replaces it with powerful. The replace method returns the new string. That returned string is printed to the output. The split method divides one string into smaller strings. It returns those parts in a list. Create a variable named message and assign Python is easy to learn. Now call the split method without passing any argument. When split is called without an argument, Python separates the string at whitespace. So, it returns the separated words as items in a list. Store the return value in a variable named words and print it. Run the program. Each word becomes a separate string. The resulting strings are placed inside a list. That is why the output contains 5 string values inside square brackets. We can also tell the split method which separator to use. Create a variable named colors. Assign a string containing red, green, and blue separated by commas. Now call the split method and pass a comma as a separator. Python looks for each comma in the string and splits the string at those positions. Store the returned list in color list. Then print color list. Run the program. The commas themselves are not included in the return values. Therefore, we get a list containing red, green, and blue. The join method combines multiple strings into one string. In a simple way, it performs the opposite type of operation to split. Let us create a list named words. Add the strings Python, is, and easy. Now, we want to combine these 3 strings with a space between them. Write a string containing one space. Call the join method on that space. Send the words list to the join method and assign the return value to message. Run the program. The string before .join acts as the separator. Here, that string contains one space. Python places that space between each item in the list. Then it returns one combined string. We can use a different separator in the same way. Create a list containing Python, Java, and C++. This time, use a comma as the string before .join. Store the returned string in result. Then print result. Run the program. The separator is now a comma. Therefore, Python places a comma between each string in the list. No spaces appear because our separator contains only a comma. We have gone through several useful string operations and methods. Python provides many more string methods. But as we always say, we will discuss them when the need arises. Conditional statements in Python. In many programs, we need to make decisions. For example, we may want to display a message if a student passes the exam and another message if the student fails. Similarly, we may want to check whether a person is eligible to vote, whether a number is positive, or whether a password is correct. To make such decisions, Python provides conditional statements. The first conditional statement is the if statement. The syntax is very simple. We begin with the keyword if. After the keyword followed by a space, we write a condition. The condition is an expression that evaluates to either true or false. After the condition, we write a colon. The colon tells Python that the statements belonging to the if block begin on the next line. The statements inside the if block must be indented. Indentation means adding spaces at the beginning of a line. By convention, Python programs use 4 spaces for each level of indentation. If you are using Visual Studio Code, it automatically adds the correct indentation when you press enter after the colon. Every statement that belongs to the if block must have the same level of indentation. Unlike many programming languages that use curly braces, Python uses indentation to identify the statements that belong to a block. Therefore, indentation is very important. If the condition is true, Python executes all the indented statements. If the condition is false, Python skips them and continues with the next statement outside the if block. Now that we understand the syntax, let us write our first if statement to check whether a student passed or failed the exam. A student passes the exam if he or she scores at least 40. Consider that a student scores 75 marks. Marks equals 75. Now we have to write the condition that checks whether the marks are at least 40. How do we write this condition? We can use the greater than or equal to operator to implement the at least condition. The condition becomes marks greater than or equal to 40. Press enter. Notice that Visual Studio Code automatically adds indentation. Inside the indented block, write print, you passed the exam. Now run the program. Since the value of marks is 75, which is greater than 40, the condition is true. Therefore, Python executes the print statement, you passed the exam. Now change the value of marks to 30. Run the program again. This time, nothing is displayed. Because the condition 30 greater than or equal to 40 is false, Python skips the code inside the if block. Notice the colon after the if condition. Also notice the indentation. If the indentation is incorrect, Python generates an error. Let us remove the indentation. Run the program again. We got an indentation error with the message that Python expected an indented block after the if statement. Coming back to the if statement, this is a simple if statement where we have only one path based on the condition. If the condition is true, we execute that path. Sometimes we need a second path that executes when the condition is false. For this, we use the if-else statement. The if part remains the same, and after it we add the else part. It starts with the else keyword followed by a colon. Then we write the statements in the else block with the same level of indentation. Let us understand the working of if-else statement. Python first checks the condition. If the condition is true, the if block is executed. Then Python continues with the statements after the if-else statement. If the condition is false, the else block is executed instead. Then Python continues with the statements after the if-else statement. Let us modify the previous example. We already have the if block that prints a message when the student passes the exam. After the if block, write else colon. Inside the else block, print, you did not pass the exam. Run the program. For the given marks, 30, the condition 30 greater than or equal to 40 is false. Therefore, the else block executes. Let us change the marks to 75 and run the program. The condition 75 greater than or equal to 40 is true. Therefore, the if block executes. Also notice that during any run, only one of the if-else blocks is executed. If the condition is true, Python executes the if block. If the condition is false, Python executes the else block. We have seen that we use the if statement when there is only one path for a condition, or the if-else statement when there are two paths for a condition. Sometimes we have more than two possible outcomes. For example, instead of simply checking pass or fail, we may want to assign grades. If marks are at least 90, the student gets grade A. Else if marks are at least 75, the student gets grade B. Else if marks are greater than or equal to 60, the student gets grade C. Otherwise, the student gets grade D. Let us go through the syntax. We start with the if-else syntax. We have an if statement. This is followed by one or more elif statements. The else statement is optional. Python checks the conditions from top to bottom. As soon as it finds the first condition that is true, it executes that block and skips all the remaining conditions. If none of the conditions are true, the else block is executed. In the example, we have more than 2 possible outcomes. In fact, there are 4 possible outcomes here. They are grade A, grade B, grade C, and grade D. Let us convert these requirements to Python statements. Run the program. Since marks is 85, Python first checks the if condition. The condition is false. Next, it checks the elif condition. This condition is true. So Python prints grade B. After finding the first true condition, Python skips all the remaining conditions. Now change the value of marks and observe how the output changes. Now let us change the marks to 68. Run the program. The first condition, 68 greater than or equal to 90, is false. So it checks the next condition. The condition, 68 greater than or equal to 75, is false. So it checks the next condition. The condition, 68 greater than or equal to 60, is true. So Python executes the corresponding block and prints grade C. You may try with different marks and observe the output. If no condition is true, then the else block executes. For all marks below 60, we should get grade D. The if statement executes code only when a condition is true. The if-else statement allows us to choose between 2 different blocks of code. The if-elif-else statement helps us handle multiple conditions. Loops allow us to execute the same block of code multiple times. We will begin with a simple problem. Let us say that we need to print the numbers from 1 to 5. Without using a loop, we could write 5 separate print statements. Run the program. The output contains the numbers from 1 to 5. However, we had to write a separate print statement for every number. What if we needed to print the numbers from 1 to 100? Writing 100 print statements would take a lot of time. The code would also become repetitive and difficult to maintain. This is where loops are useful. A loop allows us to repeat a block of code without writing the same statements again and again. Let us begin with the while loop. A while loop repeats a block of code as long as a given condition is true. We generally use a while loop when repetition depends on a condition. For example, we may want to continue asking for a password until the user enters the correct password. We may also want to repeat a task while a counter is less than a particular value. Let us first understand the syntax of a while loop. We begin with the while keyword. After the while keyword, followed by a space, we write a condition. The condition must evaluate to either true or false. After the condition, we write a colon. The statements that belong to the while loop begin on the next line. These statements must be indented. The indented statements are called the loop body. Python checks the condition before each iteration. An iteration means one execution of the loop body. If the condition is true, Python executes the indented statements. After executing the loop body, Python returns to the condition and checks it again. This process continues while the condition remains true. When the condition becomes false, Python exits the loop and continues with the next statement outside the loop. Let us use a while loop to print the numbers from 1 to 5. Create a variable named counter and assign it the value 1. This variable acts as a counter. It keeps track of the current number that we want to print. Since the requirement is to start printing from 1, we initialize counter with 1. Now write the while keyword. We want the loop to continue as long as counter is less than or equal to 5. Therefore, write the condition counter less than or equal to 5. Add a colon at the end. Press enter. Visual Studio Code adds indentation. Inside the loop, print the value stored in counter. We also need to change the value of counter during every iteration. On the next indented line, increase counter by 1. We are incrementing by 1 because we need the next integer in the next iteration. Save the 5 and run the program. The program prints the numbers from 1 to 5. Let us understand exactly how this loop works. Before the loop begins, counter contains 1. Python checks whether 1 is less than or equal to 5. The condition is true. Therefore, Python enters the loop and prints 1. Then counter equals counter plus 1 changes the value from 1 to 2. Python returns to the while condition. It checks whether 2 is less than or equal to 5. The condition is true. Therefore, Python prints 2 and changes counter to 3. Python returns to the while condition. It checks whether 3 is less than or equal to 5. The condition is true. Therefore, Python prints 3 and changes counter to 4. Python returns to the while condition. It checks whether 4 is less than or equal to 5. The condition is true. Therefore, Python prints 4 and changes counter to 5. Python returns to the while condition. It checks whether 5 is less than or equal to 5. The condition is true. Therefore, Python prints 5 and changes counter to 6. Python returns to the while condition. It checks whether 6 is less than or equal to 5. The condition is false. Therefore, Python exits the loop. The loop has completed 5 iterations. A counter-based while loop usually contains 3 important parts. The first part is initialization. Initialization gives the counter its starting value. The second part is the condition. The condition decides whether the loop should continue. The third part is the counter update. The update changes the counter during every iteration. If we forget the update, the condition may remain true forever. Let us temporarily remove the line that increases counter. Run the program. The program prints 1 forever. If you run into an infinite loop in the terminal, press Ctrl+C to interrupt the program. This happens because counter always remains 1. The condition 1 less than or equal to 5 is always true. Therefore, the loop never ends. A loop that continues forever is called an infinite loop. Now, restore the update statement. When writing a while loop, always make sure that something inside the loop can eventually make the condition false. Now let us learn about the for loop. A for loop is used to repeat a block of code for each value in a sequence. We generally use a for loop when we know which values we want to process. For example, we can use a for loop to process every item in a list or every number in a given range. For now, we will use a for loop to print the numbers from 1 to 5. Before writing the loop, we need to understand the range function. The range function generates a sequence of integers. It is commonly used with a for loop. There are 3 common ways to use the range function. The first form contains only a stop value. The second form contains a start value and a stop value. The third form contains a start value, a stop value, and a step value. Let us first consider range with only one value. When only the stop value is given, range begins from 0. It generates the values 0, 1, 2, 3, and 4. Notice that 5 is not included. The stop value is always excluded. Therefore, range of 5 generates values from 0 up to, but not including, 5. Now consider range with 2 values. The first value is the start value. The second value is the stop value. This range generates 1, 2, 3, 4, and 5. The start value is included. The stop value is excluded. Therefore, we use 6 as the stop value when we want the sequence to end at 5. The third argument is the step value. The step decides how much the value changes each time. For example, consider the following range. The sequence starts from 2. It stops before 11. The value increases by 2 during every step. Therefore, it generates 2, 4, 6, 8, and 10. If we do not provide a step value, Python uses 1 by default. Now coming back to the for loop, let us understand the syntax. We begin with the for keyword. After the for keyword, we write a variable name. This variable receives one value from the sequence during each iteration. Next, we write the in keyword. After the in keyword, we provide the sequence that we want to process. In our example, the sequence will come from the range function. After the sequence, we write a colon. The statements inside the for loop begin on the next line and must be indented. Python takes one value from the sequence, stores it in the loop variable, and executes the loop body. It repeats this process for every value in the sequence. Write the for keyword. Create a loop variable named number. Write the in keyword. Then use range with a start value of 1 and a stop value of 6. This range gives us a sequence of integers from 1 to 5. Add a colon. Press enter. Inside the indented loop body, print number. Run the program. The output is the same as the earlier while loop. During the first iteration, number contains 1. During the second iteration, number contains 2. This continues until number contains 5. After all values from the range have been processed, the loop ends. Unlike the while loop, we did not manually initialize or update the variable. The range function and the for loop handled those steps for us. Let us now modify the for loop to print the even numbers from 2 to 10. Change the range to start at 2. Set the stop value to 11 because 10 is the last value we want in the sequence. Set the step value to 2 so that odd numbers are skipped. Run the program. The value begins at 2 and increases by 2 during each iteration. The stop value 11 is excluded. Now let us learn about the break statement. The break statement immediately stops the loop. Normally, a loop continues until its condition becomes false or until all values in a sequence have been processed. However, sometimes we may want to end the loop early. For example, we may be searching for a particular value. After we find the value, there may be no reason to continue the loop. In such situations, we can use break. Let us write a for loop that processes the numbers from 1 to 10. Run the program. It prints every number from 1 to 10. Now let us stop the loop when number becomes 7. Inside the loop, before the print statement, write an if statement. Check whether number is equal to 7. Inside the if block, write break. The print statement must remain inside the for loop but outside the if block. Run the program. The loop prints the numbers from 1 to 6. When number becomes 7, the if condition is true. Python executes the break statement. The break statement immediately terminates the loop. Therefore, 7 is not printed and the remaining values are not processed. Execution continues with the first statement after the loop. Let us add a print statement outside the loop. Make sure this print statement has no indentation. Run the program. After break terminates the loop, Python continues with the statement outside the loop. Now let us learn about the continue statement. The continue statement skips the remaining statements in the current iteration. It does not terminate the entire loop. Instead, Python moves directly to the next iteration. This is the main difference between break and continue. Break ends the loop completely. Continue skips only the current iteration. Let us modify the previous program. We want to print the numbers from 1 to 10, but we do not want to print 7. Replace break with continue. Run the program. The program prints every number except 7. Let us understand what happened. For the values 1 through 6, the condition number equals 7 is false. Therefore, Python skips the continue statement and executes print. When number becomes 7, the condition becomes true. Python executes continue. The continue statement skips the remaining part of that iteration. Therefore, print is not executed for 7. Python then moves to the next iteration where number becomes 8. The loop continues normally for 8, 9 and 10. Let us compare break and continue. The break statement immediately terminates the loop. No further iterations are executed. The continue statement skips only the remaining statements in the current iteration. The loop then continues with the next iteration. Lists are one of the most commonly used data types in Python. A list allows us to store multiple values in a single variable. We will learn how to create lists, access list items, add new items, remove items, update existing items, and loop through a list. Suppose we are writing a shopping application. We need to store the items that we want to buy. One way is to create separate variables. Consider 3 items: milk, bread, and eggs. If we have hundreds of items, creating separate variables becomes difficult. Instead, we can use Python lists. A list allows us to store multiple values inside a single variable. Let us create our first list. Create a variable named shopping list. Assign the following list to it. Notice the square brackets. A list always begins with an opening square bracket and ends with a closing square bracket. The items inside the list are separated using commas. In this example, our list contains 3 strings. Now let us print the list. We can directly pass the list variable as argument to the print function. Run the program. Python displays the complete list. Lists can store any type of data. For example, numbers, strings, Boolean values, or even other lists. A list can also contain values of different data types. However, in most situations, all items represent the same kind of information. Now let us access individual items from the list. Every item in a list has an index. The first item has index 0. The second item has index 1. The third item has index 2. Notice that indexing starts from 0 instead of 1. The indexing in a list works the same way as indexing in a string, which we covered earlier in this video. Let us print the first item. Run the program. The output is milk. Now print the second item using index 1. Then print the third item using index 2. You can access any item by using its index inside square brackets. Trying to access an index that does not exist results in an index error. For example, we have only 3 elements in the list and the indexes are 0, 1 and 2. If we try to access element at index 7, then we get index error with the message list index out of range. Suppose we no longer want bread. Instead, we want butter. We can update the existing value, assign butter to the list item at index 1. Now print the list again. Run the program. The updated list now contains butter instead of bread. Now let us add another item. Python provides the append method. The append method adds a new item at the end of the list. Call the append method on the list and pass the item to the method. Run the program. Rice is added as the last item. Now let us add another item. Append sugar. Run the program again. Both items are added at the end of the list. Sometimes we want to insert an item at a particular position instead of the end. For this, Python provides the insert method. The insert method takes 2 arguments. The first argument is the index. The second argument is the value. Suppose we want to insert fruits at index 1. Run the program. Fruits is inserted at index 1. Also, please note that the remaining items automatically move 1 position to the right. Now let us remove some items. Python provides several methods for removing items. The remove method removes an item by its value. Suppose we want to remove eggs. Run the program. Eggs is removed from the list. Sometimes we want to remove an item using its index. For this, Python provides the pop method. Suppose we want to remove the item at index 2. Run the program. The item at index 2 is removed. If we call pop without providing an index, Python removes the last item. Finally, if we want to remove every item from the list, we can use the clear method. After running the program, the list becomes empty. Let us add few items to the original list. We have already learned append, insert, remove, pop, and clear methods. Now let us look at a few more useful methods. The sort method arranges the items in ascending order. Run the program. The items are now arranged alphabetically. The reverse method reverses the order of the list. Run the program. The order of the items is reversed. The count method tells us how many times an item appears. Let us count how many times milk has occurred in the list. The count method returns the number of occurrences as an integer value. We can directly print that value to output. Since milk appears only once, the output is 1. The index method returns the position of an item. Let us find the index of rice item in the shopping list and print it to output. Python prints the index of the item rice, which is 3. The copy method creates another list containing the same items. Let us copy the shopping list to a new list named newList and then print it. Now both lists contain the same values. Changes to one list do not affect the other. Now let us learn how to process every item in a list. Instead of accessing every item individually using its index, we can use a for loop. Write the syntax of for loop. For variable, use item, and for the sequence, use the shopping list. Inside the for loop, print the item. Run the program. Python takes one item from the list during each iteration. During the first iteration, item contains milk. During the second iteration, item contains bread. This continues until every item in the list has been processed. Using a loop is the most common way to process all the items in a list. Let us quickly review what we learned about lists. A list stores multiple values inside a single variable. Lists are created using square brackets. Each item has an index that starts from 0. Items can be accessed and updated using their index. New items can be added using append and insert. Items can be removed using remove, pop, and clear. Useful list methods include sort, reverse, count, index, and copy. We can process every item in a list using a for loop. Tuples are very similar to lists. However, there is one very important difference that makes tuples useful in many situations. Suppose we want to store the names of the 7 days in a week. These values never change. Monday will always be Monday. Tuesday will always be Tuesday. Since these values remain constant, a tuple is a good choice. A tuple allows us to store multiple values in a single variable, just like a list. However, unlike a list, the values in a tuple cannot be changed after the tuple is created. This property makes tuples immutable. Immutable simply means that the values cannot be modified. Let us create our first tuple. Create a variable named days. Assign it to the tuple containing the days of the week. Notice the round brackets. A tuple begins with an opening round bracket and ends with a closing round bracket. The items inside the tuple are separated using commas. Now let us print the tuple. Just like a list, we can directly pass the tuple variable to the print function. Run the program. Python displays the complete tuple. A tuple can store numbers, strings, Boolean values, and many other data types. It can even store different types of values in the same tuple. However, most tuples contain related values of the same type. Accessing items from a tuple is exactly the same as accessing items from a list. Every item has an index. The first item has index 0. The second item has index 1. The third item has index 2, and so on. Let us print the first day. Write the tuple variable followed by square brackets and then write the index inside the brackets. Since we want the first item, we use index 0. Run the program. The output is Monday. Now print the second and third days using indexes 1 and 2. Trying to access an index that does not exist results in an index error. For example, if we try to access index 10, Python displays an index error because that index is outside the tuple. Now let us see the biggest difference between lists and tuples. Suppose we try to change Monday to holiday. We try to assign the string holiday to the item at index 0. Run the program. Python generates an error. This happens because tuples are immutable. Once a tuple is created, its items cannot be changed. Similarly, we cannot append new items. We cannot insert new items. We cannot remove existing items. If we need to modify the values, we should use a list instead. Now let us compare lists and tuples. Lists are created using square brackets. Tuples are created using round brackets. Lists are mutable. This means we can add, remove, or update items. Tuples are immutable. Once created, their values cannot be changed. Lists provide many methods such as append, insert, remove, pop, sort, and reverse. Tuples provide only a few methods such as count and index because their contents cannot be modified. We have already learned these methods while working with lists. They are used in exactly the same way for tuples. Choose a list when your data is expected to change. Choose a tuple when your data should remain constant. Just like a list, we can use a for loop to process every item in a tuple. For example, let us write a for loop to print the days of the week, one day at a time. Run the program. Python takes one item from the tuple during each iteration. This continues until every item has been processed. Although tuples cannot be modified, we can still read their values and process them using loops. A set is a collection of items in which every value is unique. Suppose we are storing the subjects chosen by a student. A student cannot choose the same subject twice. For example, the student cannot choose mathematics twice. In situations like this, a set is a good choice. A set stores multiple values in a single variable. However, unlike a list, a set automatically removes duplicate values. Also, a set does not maintain the order of its items. This means we should not expect the items to appear in the same order every time we print the set. Let us create our first set. Create a variable named subjects. A set begins with an opening curly brace and ends with a closing curly brace. Inside these braces, write subject items separated using commas. Now let us print the set. Run the program. Python displays all the items in the set. Your output may not be in the same order shown on the screen. This is perfectly normal because sets are unordered collections. Now let us add another subject. Python provides the add method. The add method inserts a new item into the set. Call add method on the subjects and pass history string to that. Run the program. History is added to the set. If the item already exists, nothing changes. For example, let us try to add science, which is already there in the set. The set still contains only one copy of that item. Now let us remove a subject. Python provides the remove method. The remove method removes an item by the given value. Call remove method on subjects and pass science. Run the program. Science is removed from the set. If we try to remove an item that does not exist, Python generates a key error. For example, let us try to remove history, which is not present in the set. Run the program. We get key error. Another useful method is discard. The discard method also removes an item. However, if the item does not exist, Python does not generate an error. Let us try to remove physics from the set using discard method. Run the program. Since physics is not present, nothing happens. The program continues normally. Finally, if we want to remove every item from the set, we can use the clear method. Run the program. The set is now empty. One of the most important features of a set is that duplicate values are not allowed. Try to add mathematics once again to the subject set. We already know that mathematics is present in the set. Run the program. Notice that mathematics is not added again. The set still contains only one copy of mathematics. Python automatically ignores duplicate values. This is one of the biggest differences between lists and sets. Lists allow duplicate values. Sets automatically keep only unique values. This makes sets useful when we want to store only unique values. Now let us learn about some common set operations. Suppose another student has selected a different set of subjects. Create another set named subjects2. Now we have two sets. The first set represents the subjects selected by the first student. The second set represents the subjects selected by the second student. Let us perform different operations on these two sets. The union operation combines all unique values from both sets. Call the union method on the first set and pass the second set as the argument. Run the program. The output contains every unique subject from both sets. Notice that mathematics appears only once, even though it is present in both sets. The union operation always returns unique values. The intersection operation returns only the common values. Call the intersection method on the first set and pass the second set. Run the program. The output contains only mathematics. This is because mathematics is the only subject present in both sets. The difference operation returns the items that are present in the first set but not in the second set. Call the difference method on the first set and pass the second set. Run the program. The output contains the subjects that exist only in the first set. Subjects that are common to both sets are not included. Now let us print every subject from the subject set. Just like lists and tuples, we can use a for loop. Write the for loop. Use subject as the loop variable. Use a subject set after the in keyword. Inside the loop, print the subject variable. Run the program. Python takes one subject from the set during each iteration. This continues until every subject has been processed. Notice that the order may be different every time you run the program. This is completely normal because sets are unordered collections. Let us compare lists and sets. Lists allow duplicate values. Sets do not allow duplicate values. Lists maintain the order in which items are added. Sets do not guarantee the order of their items. Lists support indexing, so we can access items using their position. Sets do not support indexing because they are unordered. Both lists and sets are mutable, which means we can add and remove items after they are created. Choose a list when the order of items is important or when duplicate values are allowed. Choose a set when you need to store only unique values. A dictionary is a collection of key-value pairs. A key is used to identify a value. Instead of accessing data using an index, dictionaries allow us to access data using keys. Suppose we want to store information about a student. The student has a name. The student has an age. The student belongs to a class. One way is to create separate variables. However, all these values belong to the same student. A dictionary allows us to group related information together. Each value is associated with a key. For example, the key name stores the student's name. The key age stores the student's age. The key class stores the student's class. Let us create our first dictionary. Create a variable named student. A dictionary begins with an opening curly brace and ends with a closing curly brace. Each item consists of a key followed by a colon followed by its value. For the name, write string origin. Different key value pairs are separated using commas. For the age, write integer value 15. For the class, write integer value 10. Now let us print the dictionary. Run the program. Python displays the complete dictionary. Notice that every value is associated with a key. Now let us access individual values from the dictionary. Unlike lists and tuples, dictionaries do not use indexes. Instead, they use keys. Suppose we want to print the student's name. Write the dictionary variable followed by square brackets. Inside the square brackets, write the key, name. Run the program. Python displays Arjun. Similarly, let us print the student's age. Now, pass the key age. Run the program. Python displays 15. If we try to access a key that does not exist, Python generates a key error. For example, if we try to access the key marks, Python displays a key error because that key is not present in the dictionary. Now let us add another piece of information. Suppose we also want to store the student's city. Write the dictionary variable. Inside square brackets, write the key city. Assign the value Hyderabad. Now print the dictionary. Run the program. The new key value pair is added to the dictionary. Updating a value is very similar. Suppose the student's class changes from 10 to 11. Write the dictionary variable. Inside the square brackets, write the key class. Assign the new value 11. The previous value is replaced with the new value. Now let us remove a key value pair. Python provides the pop method. The pop method removes a key and its corresponding value. Call the pop method on the student dictionary. Pass the key city as the argument. The city key and its value are removed from the dictionary. If we want to remove every key value pair from the dictionary, we can use the clear method. The dictionary is now empty. Let us restore the student dictionary. Now let us print every key and its value. Write a for loop. Use key as the loop variable. Loop through student. Inside the loop, print the key followed by its value. To access the value, use the current key inside square brackets. Python takes one key during each iteration. It then uses that key to retrieve the corresponding value. The output contains every key along with its value. Another common way to loop through a dictionary is by using the items method. The items method returns both the key and the value together. So, we use two variables in the for loop. One for the key and one for the value. The output is the same. However, this approach gives us both the key and the value directly. Let us quickly review what we learned about dictionaries. A dictionary stores data as key value pairs. Dictionaries are created using curly braces. Values are accessed using keys instead of indexes. New key value pairs can be added by assigning a value to a new key. Existing values can be updated by assigning a new value to an existing key. Key value pairs can be removed using the pop method. We can loop through dictionaries using a for loop or the items method. A function is a reusable block of code that performs a specific task. Functions help us avoid writing the same code again and again. They also make programs easier to organize, read, and maintain. Suppose we want to display a welcome message for different users. Without using a function, we may write the same print statement many times. This program works. However, the same statement is repeated. If we later want to change or correct the message, we have to update it in every place. Instead, we can place the statement inside a function. Then we can call the function whenever we need to display the message. The function also becomes the single place where we need to update the code. Let us create our first function. The general syntax of a function is as follows. We begin with the def keyword. The word def is short for define. After the def keyword, followed by a space, we write the function name. The function name follows the same naming rules as variables. After the function name, we write opening and closing parentheses. Then we write a colon. The statements that belong to the function begin on the next line. These statements must be indented. The indented statements are called the function body. Let us create a function named welcome. We have now defined the function. However, defining a function does not execute it. Python only stores the function so that we can use it later. To execute a function, we call it. To call a function, write the function name followed by opening and closing parentheses. Run the program. Python first reads the function definition. When it reaches the function call, it executes the statements inside the function. We can call the same function multiple times. Run the program. The message is displayed 3 times. This is the main benefit of a function. Rewrite the code once and reuse it whenever needed. The welcome function always displays the same message. Suppose we want to welcome different users by name. We could create a separate function for every user. However, that would again create repeated code. Instead, we can pass information to a function using parameters. A parameter is a variable written inside the parentheses of a function definition. Let us modify the welcome function. Inside the parentheses, write the parameter name. The function now has one parameter named name. This parameter receives a value when the function is called. Now modify the print statement so that it displays a welcome message for that person. Call the function and pass the string Arjun inside the parentheses. Run the program. The value Arjun is passed to the function. Inside the function, that value is stored in the parameter called name. The function then uses name inside the f string. The value that we pass while calling a function is called an argument. The parameter is the variable in the function definition. The argument is the actual value given during the function call. Now call the same function with different arguments. Run the program. The same function works with different values. A function can have more than one parameter. Suppose we want to display both the name and the course of a student. Add another parameter named course. Separate the parameters using a comma. Let us print the course information as well using another print statement. Please observe that the 2 print statements in the function body are indented. Now call the function with 2 arguments. Run the program. The first argument, Arjun, is assigned to the first parameter, name. The second argument, Python, is assigned to the second parameter, course. Therefore, the order of arguments is important when we use positional arguments. So far, our functions have only printed messages. A function can also calculate a value and send it back to the place where it was called. For this, we use the return statement. Let us create a function that adds 2 numbers. Create a function named add. Give it 2 parameters named number1 and number2. Inside the function, we add the 2 numbers and store the result. Then we use the return keyword to send the result back. Write the return keyword followed by a space and then write the value that we want to send back. Now call the function and pass 10 and 20 as arguments. If we run the program now, nothing is displayed. This is because the function returns the value, but we have not printed or stored it. Let us store the return value in a variable named total. Now print total. Run the program. The function calculates 10 plus 20. The return statement sends 30 back to the function call. That return value is stored in total. When Python executes a return statement, the function ends immediately. Any statements written after return in the same function are not executed. For example, add a print statement after return. Run the program. The message calculation completed is not displayed. Python leaves the function as soon as it reaches return. Therefore, statements that need to run must usually be written before the return statement. Sometimes we want a parameter to have a value even when no argument is provided. For this, we can use a default parameter. Let us return to the welcome function. Suppose most students are learning Python. Write an equal sign after course and assign the string Python. Python becomes the default value of the course parameter. If no argument is passed for the course parameter, Python is used. Now call the function with only the name argument. Run the program. Since we did not provide a value for course, Python uses the default value, which is Python. Now call the function with two arguments. Run the program. The provided argument replaces the default value. A default parameter is used only when no argument is supplied for it. Parameters without default values should come before parameters with default values. If we place a required parameter after a default parameter, Python generates a syntax error. Therefore, keep required parameters first and default parameters after them. Until now, we passed arguments according to their position. These are called positional arguments. For example, consider the following function. Call the function using positional arguments. The first argument goes to name, the second argument goes to age, the third argument goes to course. We can also pass arguments using parameter names. These are called keyword arguments. Write each parameter name followed by an equal sign and its value. Name equals Arjun, age equals 15, and course equals Python. Run the program. One benefit of keyword arguments is that we do not have to follow the original parameter order. Let us change the order. Pass course as the first argument. Run the program. The output remains correct. Python matches each argument with the parameter name. Keyword arguments can make function calls easier to read, especially when a function has several parameters. We can use positional and keyword arguments in the same function call. However, positional arguments must come before keyword arguments. For example, this is valid. Here, Arjun is a positional argument. Age and course are keyword arguments. The correct order is positional arguments followed by keyword arguments. Let us combine what we have learned. Create a function named calculateTotal. Give it three parameters. The first parameter is price. The second parameter is quantity with a default value of 1. The third parameter is discount with a default value of 0. Now call the calculateTotal function with only the price argument. Run the program. Since quantity is not given, Python uses 1. Since discount is not given, Python uses 0. Therefore, price times quantity is 100 times 1, which is 100. Then the discount is subtracted from the total, which is 100 minus 0. The value of total remains 100. Therefore, the output is 100. Now call the function again. Pass 100 as the positional argument for price. Then use the keyword argument quantity and assign it the value 3. Run the program. This time, price is 100 and quantity is 3. The discount parameter still uses its default value of 0. Therefore, the function returns 300. Now let us also provide a discount of 50. Add the keyword argument discount and assign it the value 50. Run the program. The function first multiplies 100 by 3. This gives us 300. It then subtracts the discount of 50. Therefore, the function returns 250. Let us quickly review what we learned about functions. A function is a reusable block of code that performs a specific task. We create a function using the def keyword. We call a function using its name followed by parentheses. Parameters allow a function to receive values. Arguments are the actual values passed to the function. The return statement sends a value back to the caller. Default parameters provide values when arguments are not supplied. Keyword arguments allow us to pass values using parameter names. Functions help reduce repeated code and make programs easier to organize. Scope tells us where a variable can be accessed in a program. A variable may be available throughout the program, or it may be available only inside a particular function. A function may create variables while performing its task. However, those variables are not always available everywhere in the program. Python controls where a variable can be accessed. The area in which a variable is available is called its scope. Let us understand this step by step. A variable created inside a function is called a local variable. A local variable belongs to that function. It can be accessed only inside the function in which it was created. Let us write a simple example. Create a function named showMessage. Inside the function, create a variable named message. Assign the string welcome to Python to it. Now print the message variable inside the function. Call the function. The program works correctly. The message variable was created inside the showMessage function. The print statement is also inside the same function. Therefore, the function can access the message variable. Now let us try to print the message variable outside the function. After the function call, write another print statement. Pass the message variable to it. Run the program. The first print statement works. It displays welcome to Python. However, the second print statement generates an error. Python tells us that message is not defined outside the function. This happens because message is a local variable. It exists only inside the showMessage function. The code outside the function cannot access it. This is called local scope. We can think of a function as having its own private working area. Variables created inside that function remain inside that working area. The function can use those variables while it is running. Code outside the function cannot directly access them. Different functions can create local variables with the same name. These variables are separate from each other. Let us create two functions. The first function is named showStudent. Inside it, create a variable, name, and assign argent to it. Then print name. Now create another function named showTeacher. Inside it, create another variable, name, assign Roshan to it. Then print name. Call both functions. Run the program. Both functions use a variable, name. However, they do not interfere with each other. The name variable inside showStudent function belongs only to showStudent function. The name variable inside showTeacher belongs only to showTeacher function. Each function has its own local scope. Function parameters also behave like local variables. They can be used only inside the function. Let us create a function named greet. Give it one parameter, name. Inside the function, print a welcome message using the name parameter. Call the function and pass Arjun as the argument. The name parameter receives the value Arjun. That parameter is available inside the greet function. It is local to the function. Let us try printing the name outside the function. If we try to print name outside the function, Python generates a name error. A variable created outside all functions is called a global variable. A global variable can usually be accessed from anywhere in the program. This includes code outside functions and code inside functions. Let us write an example. Create a variable named course outside the function. Assign the string Python to it. Now create a function named showCourse. Inside the function, print the course variable. Call the function. The course variable was created outside the function. Therefore, it is a global variable. The showCourse function can read the global variable. Let us also print course outside the function. The first print statement is inside the function. The second print statement is outside the function. Both statements can access the global variable. Now let us see what happens when a local variable and a global variable have the same name. Create a global variable named message. Assign the string global message. Now create a function named showMessage. Inside the function, create another variable named message. Assign the string local message. Then print message inside the function. After calling the function, print message outside the function. Let us understand the execution step by step. Python begins at the first line. It creates the global variable named message and stores the string global message in it. Next, Python reads the definition of the showMessage function. At this point, the function body does not run. Python only stores the function definition for later use. Then Python reaches the function call showMessage. Now the function starts running. Inside the function, Python creates a new local variable named message. This local variable stores the string local message. The local variable has the same name as the global variable, but it is a different variable. When Python reaches print message inside the function, it first looks for message in the local scope. It finds the local variable, so it prints local message. The function then finishes. After the function call, Python continues with the next statement outside the function. Now Python reaches print message outside the function. Since this statement is outside the function, the local variable is not available here. Python uses the global variable named message. Therefore, it prints global message. This is why the output first shows local message and then global message. Creating the local variable did not update or replace the global variable. The two variables have the same name, but they belong to different scopes. Reading a global variable inside a function is simple. However, changing it requires special handling. Let us create a global variable named count and assign 0 to it. Now create a function named increaseCount. Inside the function, try to increase count by 1. Python generates an error. This happens because assigning a value to count inside the function makes Python treat it as a local variable. However, the function tries to read that local variable before giving it a value. If we really need to modify a global variable inside a function, we can use the global keyword. Inside the function, write the global keyword followed by the variable name. Now increase count by 1. The global statement tells Python that the count inside the function refers to the global variable. Let us quickly review what we learned about scope. Scope determines where a variable can be accessed. A variable created inside a function is a local variable. A local variable is available only inside that function. Function parameters are also local to the function. A variable created outside all functions is a global variable. A function can read a global variable. A local variable can have the same name as a global variable. In that case, the function uses the local variable. The global keyword allows a function to modify a global variable. However, using parameters and return values is often clearer and safer. Python provides many ready-to-use functions. These functions are called built-in functions. A built-in function is already available in Python. We do not need to create it, and we do not need to import it from another file. We can call it directly whenever we need it. We have already used several built-in functions in this course. We have used the print function in almost every program to display output. We have used the input function to receive a value from the user. During type conversion, we use the int, float, and star functions. The int function converts a value to an integer. The float function converts a value to a floating point number. The star function converts a value to a string. Python provides many other built-in functions. We do not need to memorize all of them now. We will learn and use additional built-in functions whenever they are needed. The len function returns the number of items in a value. We commonly use it with strings, lists, tuples, sets, and dictionaries. Let us create a list of marks. Now call the len function. Pass the marks list as the argument. Store the return value in a variable named count. Run the program. The marks list contains 5 items. Therefore, len returns 5. The len function does not return the values themselves. It returns only the number of items. The sum function adds all the numeric values in a collection. Let us use the same marks list. Call the sum function and pass marks as the argument. Store the return value in a variable named total. Run the program. Python adds all 5 marks and returns the total. The sum function should be used with numeric values. If the collection contains strings, sum cannot add them in this way. The min function returns the smallest value. Call the min function and pass the marks list. Run the program. Python checks all the values in the list. The smallest value is 68. Therefore, min returns 68. The max function returns the largest value. Call the max function and pass the same list. Run the program. Python checks all the values. The largest value is 91. Therefore, max returns 91. Now let us combine two built-in functions. We can find the average mark by dividing the total by the number of marks. Use sum to calculate the total. Use len to find how many values are present. Run the program. The sum function returns the total. The len function returns the number of marks. Python divides the total by the count and gives us the average. This is a good example of using built-in functions together. The round function rounds a number. It can round a decimal value to the nearest whole number. Let us use the average value. Run the program. The average is 80.8. The nearest whole number is 81. Therefore, round returns 81. The round function can also keep a specific number of decimal places. Pass the number as the first argument. Pass the number of decimal places as the second argument. Run the program. The second argument is 2. Therefore, Python rounds the value to 2 decimal places. The sorted function returns the items in sorted order. Let us use the same marks list. Call the sorted function and pass marks as the argument. Store the result in a variable named sorted marks. Run the program. The values are arranged from smallest to largest. The sorted function returns a new list. It does not change the original list. Let us print the original list to confirm this. The original list remains unchanged. We can also sort in descending order. Pass reverse equals true as the second argument. Run the program. The values are now arranged from largest to smallest. Let us quickly review what we learned. Built-in functions are ready-to-use functions provided by Python. We have already used print, input, int, float, and star earlier in the course. The len function returns the number of items. The sum function adds numeric values. The min function returns the smallest value. The max function returns the largest value. The round function rounds a number. The sorted function returns the items in sorted order. Python provides many more built-in functions. We will learn them when they become useful in other sections. A module is a Python file that contains reusable code. A module may contain variables, functions, classes, or other Python statements. Modules help us organize large programs into smaller files. They also allow us to reuse code without writing it again. So far, most of our programs have been written inside a single Python file. This works well for small programs. However, as a program becomes larger, keeping all the code in one file can make it difficult to read and maintain. We may also need the same function in more than one program. Instead of copying the function into every file, we can place it inside a module. Then we can import that module wherever the function is needed. Python also provides many modules as part of its standard library. These modules contain useful functions for common tasks. We shall go through some of those modules with examples. We will also learn how to create and import our own module. Before we can use the code from a module, we need to import it. We begin with the import keyword. After the import keyword followed by a space, we write the name of the module. Once the module is imported, we can access the functions and values provided by it. We write the module name followed by a dot, followed by the function or value that we want to use. The dot tells Python to access something that belongs to the module. Let us begin with the math module. Import the math module. The math module provides functions and values for mathematical operations. In Visual Studio Code, to get a glance of those functions and values, on Mac you can hold Command key and click on the module name. On Windows, you can hold Control key and click the module name. This opens the definition or type information for the module. Depending on the Python installation and editor setup, Visual Studio Code may open a .py file or the module's source file. There, we can view the available values, functions, and classes. Now let us find the square root of 64. Call the sqrt function from the math module. First, write math. Then write a dot. After the dot, write sqrt. Pass 64 as the argument. Store the return value in result variable and print it. Run the program. The square root of 64 is 8. Python displays 8.0 because the function returns a floating point value. The math module also provides the value of pi. Let us print the value of pi. Write math followed by a dot followed by pi. Run the program. Python displays the value of pi. We can use this pi value to calculate the area of a circle. Create a variable named radius and assign 5 to it. The formula for the area of a circle is pi multiplied by radius squared. We can write radius times radius, or we can use exponential operator to find the square of radius. Any variation is fine. Print the area. Python uses the value of pi from the math module and calculates the area. We do not need to manually type an approximate value such as 3.14. Sometimes we need only one function from a module. Instead of importing the complete module, we can import a specific item. The syntax is as follows. Let us import only the square root function from the math module. Since we are importing sqrt function directly, there is no need to specify math dot before the function call. We can call the square root function directly. Please note that we are not importing the complete math module. For beginners, importing the complete module is often easier to understand because the module name remains visible. Now let us learn about the datetime module. The datetime module helps us work with dates and times. We can use it to get the current date and time, create specific dates, or calculate differences between dates. Import the datetime module. Now let us get the current date and time. The datetime module contains a class that is also named datetime. From that class, we can call the now method. Write datetime followed by a dot followed by datetime followed by a dot followed by now. Store the return value in current time variable and print it. Run the program. Python displays the current date and time from the computer. The output includes the year, month, day, hour, minute, second, and possibly microseconds. We are not limited to the modules provided by Python. We can create our own modules. Any Python file can be used as a module. Let us create a small module containing reusable functions. In Visual Studio Code, create a new Python file. Name it calculator.py. Inside this file, create a function named add. Give it two parameters named number1 and number2. Return their sum. Now create another function named multiply. Give it the same two parameters. Return their product. The calculator.py file is now our custom module. Create another Python file in the same folder. Name it main.py. Inside main.py, import the calculator module. Now call the add function from the calculator module. Write calculator followed by a dot followed by add. Pass 10 and 20 as arguments. Store the return value in a variable named total. Now let us use the multiply function. Call calculator.multiply. Pass 5 and 8 as arguments. Store the result in product. Print both total and product. Run main.py. Python finds calculator.py in the same folder. It imports the code from that file. Then main.py calls the add function from the calculator module, executes the add function with the given arguments and stores the return value in total variable. Then imports the multiply function from the calculator module, executes the multiply function with the given arguments 5 and 8 and stores the return value in product variable. The add and multiply functions are written only once inside calculator.py. We can use them from main.py whenever needed. For this simple example, calculator.py and main.py should be in the same folder. If Python cannot find the module, it generates a module not found error. The import statement should use the file name without the .py extension. For example, the file is named calculator.py. The import statement is import calculator. Let us quickly review what we learned about modules. A module is a Python file containing reusable code. Modules help us organize programs and avoid repeating code. We import a module using the import keyword. We can create our own module by placing reusable code inside a separate Python file. We can then import that file into another Python program. Python provides many more modules as part of its standard library. We will learn and use them whenever they are needed in future programs. Errors may occur while a Python program is running. When an error occurs during execution, Python usually stops the program and displays an error message. Error handling allows us to respond to certain errors without allowing the program to stop unexpectedly. We will use division by zero to learn about exceptions, try, except, and finally. Let us begin with a simple division program. Create a variable named number and assign 100 to it. Create another variable named divisor and assign 0 to it. Now divide number by divisor. Store the result in a variable named result. Run the program. Python generates an error called zero division error. This error occurs because division by zero is not allowed. Python successfully creates the number and divisor variables. It then reaches the division statement. At this point, Python tries to divide 100 by 0. Since the operation is not allowed, Python raises a zero division error. The program stops immediately. Therefore, the print statement after the division is not executed. An error that occurs while a program is running is called an exception. Zero division error is one type of exception. Python has many other exception types. We will learn about them whenever they are needed. For now, let us learn how to handle this exception. Python provides try and except for handling exceptions. The try block contains code that may raise an exception. The except block contains the code that should run when a particular exception occurs. Let us update the division program. First, write the try keyword followed by a colon. The statements inside the try block must be indented. Move the division statement inside the try block. This statement is placed inside the try block because it may raise a zero division error. If the division succeeds, we want to print the result. Add the print statement inside the try block after the division. After the try block, write except zero division error followed by a colon. Writing zero division error after except tells Python that this block should handle a division by zero exception. The statements inside the except block must also be indented. Inside the except block, print a clear message. Run the program. Let us understand the execution step by step. Python first creates the number variable and stores 100 in it. It then creates the divisor variable and stores 0 in it. Next, Python enters the try block. Inside the try block, Python attempts to divide 100 by 0. This operation raises a zero division error. As soon as the exception occurs, Python stops executing the remaining statements inside the try block. Therefore, the print result statement is skipped. Python then looks for an except block that can handle zero division error. It finds the matching except block. Python executes the statement inside that block and displays the message. The exception is now handled. Therefore, the program does not stop with Python's usual error message. Now let us see what happens when the division is valid. Change the value of divisor from 0 to 5. Run the program. Let us understand what happened. Python enters the try block. It divides 100 by 5. The division succeeds, so result contains 20.0. Python then prints the result. Since no zero division error occurs, the except block is skipped. Therefore, the try block runs when the operation succeeds. The except block runs only when the specified exception occurs. We should usually mention the specific exception that we expect. In this program, we expect a zero division error. Therefore, we write zero division error after the except keyword. It also prevents unrelated errors from being hidden. If another type of exception occurs, this except block will not handle it. We can add other except blocks later when a program needs to handle different exception types. Python also provides the finally block. The finally block contains code that runs whether an exception occurs or not. Let us add a finally block to our program. After the except block, write the finally keyword followed by a colon. The statements inside the finally block must be indented. Inside the finally block, print division attempt completed. Run the program. Let us understand the execution. The division raises a zero division error. The except block handles the exception. After that, the finally block runs. Now change divisor to 5. Run the program again. This time, the division succeeds. The try block prints 20.0. The except block is skipped. The finally block still runs. Therefore, the finally block executes in both situations. It runs when an exception occurs. It also runs when no exception occurs. Let us review the execution flow. Python first enters the try block. If every statement inside the try block succeeds, the except block is skipped. Python then executes the finally block. If a matching exception occurs inside the try block, Python stops the remaining statements in that block. It then executes the matching except block. After the except block, Python executes the finally block. Therefore, finally runs at the end in both successful and unsuccessful situations. In this section, we will learn how to open a file, read its contents, write new content, append additional content, and use the with open statement. We will use a simple text file named notes.txt. In Visual Studio Code, create a new file in the same folder as the Python program. Name the file notes.txt. Inside the file, write the following text. Save the file. Now create a Python file named main.py in the same folder. Keeping both files in the same folder makes this example easier to follow. Python provides the open function for opening files. The first argument is the name or path of the file. The second argument is the mode in which we want to open it. The mode tells Python what operation we want to perform. For example, we may want to read the file, write to it, or append content to it. The most common modes are R, W, and A. The letter R means read. The letter W means write. The letter A means append. Let us open notes.txt in read mode. Call the open function. Pass notes.txt as the first argument. Pass the string R as the second argument. The open function returns a file object. The file object represents the opened file. We store it in the variable named file so that we can work with it. If we do not specify a mode, Python opens the file in read mode by default. However, let us explicitly specify the mode so that the purpose is clearer. Now let us read the complete contents of the file. Call the read method on the file object. Store the returned text in a variable named content. Now print content. Run the program. The read method reads the entire file and returns its contents as a string. Python stores that string in the variable named content. The print function then displays it. After working with a file, we should close it. Call the close method on the file object. Closing a file tells Python that we have finished using it. This also releases the resources associated with the file. Forgetting to close a file may not cause an immediate problem in a small program. However, closing files properly is an important programming practice. Python provides a better and safer way to work with files. We can use the with statement together with open. The general syntax is as follows. We begin with the with keyword. Then we call the open function. After that, we write the as keyword followed by a variable name. The variable refers to the open file. The statements that work with the file are written inside the indented block. When the block finishes, Python closes the file automatically. Therefore, we do not need to call the close method ourselves. Let us rewrite the reading program using with open. Run the program. The output is the same. Python opens the file before entering the with block. The read method reads the complete contents. The print function displays the text. When the indented block ends, Python closes the file automatically. This is the recommended way to work with files in Python. Now let us learn how to write content to a file. To write to a file, we open it in write mode. Write mode uses the letter W. Let us replace the existing content of notes.txt. Use with open. Pass notes.txt as the file name. Pass W as the mode. Inside the with block, call the write method. Pass the text that we want to store. Run the program. Now open notes.txt. The file contains the new sentence. The write method replaces the old content with the new content. This happens because write mode replaces the existing contents of the file. Therefore, we should use write mode carefully. If the file does not already exist, write mode creates it. For example, change the file name to output.txt. Also, let us change the content we are writing into the file. Run the program. Python creates output.txt in the current folder. It then writes the given text into it. Sometimes we want to add new content at the end of the file. For this, we use append mode. Append mode uses the letter A. Let us add another line to notes.txt. Open the file in append mode. Inside the block, call the write method. Add a new line character before the new sentence if needed. Run the program. Now open notes.txt. The new sentence is added after the existing content. Append mode does not remove the existing text. It adds new content at the end of the file. Write mode and append mode both allow us to store text in a file. However, they behave differently. Write mode replaces the existing contents. Append mode keeps the existing contents and adds new text at the end. Use write mode when you want to create fresh content. Use append mode when you want to preserve the existing content and add more. If we try to open a file in read mode and the file does not exist, Python raises a file not found error. For example, suppose we write the wrong file name. If the actual file is named notes.txt, Python cannot find note.txt. Therefore, it raises a file not found error. Check the file name, spelling, extension, and file location whenever this error occurs. Object-oriented programming is a way of organizing related data and behavior together. It allows us to create objects that contain their own values and functions. In this lesson, we will learn about classes, objects, constructors, instance variables, methods, and basic inheritance. We will use a simple student example throughout most of this section. A class is a blueprint for creating objects. It describes what data an object should contain and what actions it should perform. The general syntax is as follows. We begin with the class keyword. After that, we write the class name. Class names usually begin with a capital letter. Then we write a colon. The statements that belong to the class are written inside the indented block. Let us create an empty student class. The pass statement allows us to create an empty class without causing an error. At this point, the student class does not contain any data or methods. An object is an actual value created from a class. The class acts as the blueprint. The object is created using that blueprint. Let us create an object from the student class. Student is the class. Student1 is the object. The parentheses after student create a new object. We can create many objects from the same class. Student1 and Student2 are separate objects created from the same student class. A constructor is a special method that runs automatically when an object is created. In Python, the constructor is written as _init _. The name begins and ends with 2 underscore characters. The constructor is commonly used to give initial values to an object. Let us add a constructor to the student class. The constructor has 3 parameters. The first parameter is self. The other parameters are name and age. When we create an object, we provide values for name and age. Python automatically calls the constructor. The string Arjun is passed to the name parameter. The value 15 is passed to the age parameter. The self parameter refers to the current object. When we write self.name, we are storing a name inside that particular object. When we write self.age, we are storing an age inside that particular object. The name on the right side is the value received by the constructor. The self.name on the left side becomes a variable that belongs to the object. The same is true for age. Python passes the current object to self automatically. Therefore, we do not provide a value for self when creating an object. Variables that belong to an object are called instance variables. In our student class, name and age are instance variables. Each object stores its own values. Let us create another object student2 of class type student. Also, let us print the details of both the objects. Run the program. Student1 stores the name Arjun and the age 15. Student2 stores the name Roshan and the age 16. Although both objects come from the same class, they contain different values. A method is a function defined inside a class. A method usually performs an action using the data stored in an object. Let us add a method named introduce. The introduce method has the self parameter. This allows the method to access the current object's instance variables. Inside the method, self.name refers to the object's name. Self.age refers to the object's age. To call a method, write the object name followed by a dot and the method name. Instead of printing instance variables in separate print statements, let us call the introduce method on the student objects. Run the program. When student1.introduce is called, self refers to student1. Therefore, the method uses Arjun and 15. When student2.introduce is called, self refers to student2. Therefore, the method uses Roshan and 16. Let us understand the execution step by step. Python first reads the student class definition. At this point, the constructor and method do not run. Python only stores the class definition. Then Python reaches a statement that creates student1. The student class is called with Arjun and 15. Python creates a new object. It automatically calls the constructor. Inside the constructor, self refers to the new student1 object. Python stores Arjun in student1.name. It stores 15 in student1.age. The same process happens when student2 is created. Later, Python reaches student1.introduce. The introduce method runs with self referring to student1. It prints the values stored in student1. Then, student2.introduce runs and prints the values stored in student2. A class is a blueprint. An object is an actual value created from that blueprint. The class defines the common structure. Each object stores its own data. Inheritance allows one class to receive features from another class. The existing class is called the parent class. The new class is called the child class. Let us create a simple parent class named person. The person class contains a greet method. Now create a student class that inherits from person. Write person inside parentheses after student. Person is the parent class. Student is the child class. Because student inherits from person, a student object can use the greet method. Run the program. The student class does not define its own greet method. However, it inherits the greet method from the person class. Therefore, the student object can call it. Inheritance helps us reuse code from an existing class. Before you leave, if you like this video, give it a like and subscribe to our Program Guru channel. That would mean a lot to this channel. It is time to wrap up this Python course for beginners. After completing this video, try going through the course once again. But this time, write the code yourself in the editor for each concept and example, run it, and observe how it works. Practicing this way will help you become more familiar with Python and more confident in writing Python code on your own. In this course, we have covered the fundamentals of Python. In our upcoming videos, we will explore these concepts in much more depth with dedicated videos for each topic. Thank you for watching and keep practicing Python.